Tonight, we're going to look at something that already feels familiar: images from a space telescope. Pixels arranged into galaxies, faint smudges of light labelled with distances so large they blur into abstraction. You have seen them shared, commented on, quietly absorbed into the background of modern life, treated as pictures from far away rather than messages from long ago. They appear calm, static, almost decorative, as if the universe were posing patiently for a camera that finally learned how to see in the dark. At first glance, nothing seems demanding here. Light is light. A telescope is a telescope. An image is an image. The past feels like a place you could point to, mark with a number, and move on from. Billions of years sound impressive, but distant, safely compressed into captions and headlines. The beginning of time feels like a phrase, not a location. It feels symbolic rather than physical. Yet even in this familiarity, something is misaligned. These images do not behave like ordinary photographs. They do not sit in the present. They do not show objects as they are. They arrive already delayed, already altered, already stretched by conditions that never occur on human scales. The light in them has crossed environments no laboratory can reproduce, obeying limits that intuition was never shaped to handle. What looks still has been travelling longer than civilization has existed. What looks small contains more matter than entire regions of nearby space. You stand on a planet where light feels immediate. A sunrise follows the sun. A reflection follows your movement. Cause and effect seem tightly coupled, almost touching. History unfolds at the pace of breath, seasons, lifetimes. Against that background, the universe appears generous for allowing itself to be seen at all, as though distance were merely an inconvenience rather than a structural barrier. The telescope did not remove that barrier. It did not pierce time. It did not reveal a beginning in any simple sense. It collected light that had already survived a journey defined by expansion, cooling, and loss, and it arranged that light into forms your eyes can register. What you are about to move through is not a revelation, but a gradual correction, where familiar ideas are placed under pressures they were never designed to withstand. Nothing here requires urgency. Nothing demands belief. The scale will do the work on its own, slowly, quietly, until the shape of things begins to feel different without effort. Now let's begin. You begin close to home, where distance still feels manageable and time still feels obedient. Light behaves politely here. It leaves the sun and reaches Earth in a little over 8 minutes, a delay short enough to be ignored in daily life, short enough that cause and effect still feel welded together. When clouds move, the shadows respond. When night falls, it feels immediate. The universe seems to cooperate with the rhythm of human perception. Yet even here, the delay is already present, already unavoidable. Every moment of daylight you have ever experienced was already minutes old by the time it touched your skin. The sun you see is not the sun as it is, but as it was, slightly earlier, slightly younger. The difference is small enough to dismiss, but it never goes away. It is built into the structure of space itself. Light does not arrive when it is created. It arrives when it can. From Earth, this delay rarely matters. 8 minutes do not disrupt history. They do not alter memory. They do not outlast attention. Human life unfolds comfortably inside gaps that small. You are free to think of the present as something shared between events and awareness. Now the scale shifts outward, not dramatically, just enough to loosen that comfort. The nearest star beyond the sun sits a little more than 4 light-years away. When you look at it, the light has been travelling since before the last few years of your life unfolded. Any change that occurred there after the light left has not yet arrived. The star you see is already outdated, but not ancient. The delay fits inside a human lifetime. At this distance, history begins to creep in. 4 years can hold elections, disasters, discoveries, births. It can hold the rise and fall of plans that once felt permanent. The star remains unchanged to your eyes while entire chapters of human life pass beneath its light. Still, intuition holds. 4 years feels long, but not alien. Memory can stretch that far without strain. As you move farther, intuition begins to thin. Tens of light years, hundreds. The night sky fills with stars whose light left before you were born. Some began their journey before your parents met. Others departed while the outlines of the modern world were still forming. Railways expanding, cities electrifying, wars reorganizing borders. Each point of light becomes a quiet archive, carrying a version of reality that no longer exists. The telescope's mirrors gather these photons without judgment. They do not distinguish between the light of a stable star and the light of a system that has already changed. They simply collect what arrives. The images appear steady, but they are layered with time. Every bright point carries a different age, a different departure date, a different historical context. Human intuition is not built for this. The mind prefers simultaneity. It wants a shared now, a single moment stretched across space, but space refuses that request. Distance enforces delay, and delay fractures the present into countless versions, each one valid where it exists. At hundreds of light years, entire generations pass between emission and arrival. Languages shift, technologies appear, beliefs reorganize themselves. A civilization could rise and fall while its starlight is still en route, crossing the emptiness indifferent to what unfolds below. The telescope does not see these changes. It sees the past as it was, preserved by travel time alone. You remain emotionally intact here. The distances are large, but the idea of generation still belongs to human scale. A few hundred years can be imagined. It can be named. It fits into textbooks and family trees. The light feels delayed, but not unreachable. As distance grows into thousands of light years, the delay swells beyond personal memory. The light now left its source before modern science existed as a discipline, before telescopes carried mirrors rather than lenses, before electricity threaded itself through cities. You're looking at light that departed while the frameworks you used to understand it had not yet been invented. History thickens, empires collapse, religions spread, populations migrate, written records become sparse. The human world rearranges itself multiple times before the photons arrive. The stars appear unchanged, patient, unaffected by the turbulence beneath their ancient light. The telescope sharpens these points, resolving structures, colours, densities. It does not collapse the delay. It does not update the scene. It simply renders the past more clearly than ever before. Clarity does not equal immediacy. Precision does not erase time. By the time you reach the scale of the galaxy, intuition finally begins to resist. Tens of thousands of light years span the width of the Milky Way. Light crossing this distance left its source when humans were just beginning to record their thoughts in durable form. Writing itself was young. Agriculture was still reshaping societies. The idea of science as a method did not exist. Yet the galaxy appears whole. Spiral arms curve gracefully. Dust lanes cut across starlight. The structure feels stable, architectural, almost timeless. This is an illusion produced by delay. What you see is not a snapshot but a composite of different eras stitched together by travel time. The telescope does not privilege one era over another. It assembles whatever arrives simultaneously at its mirrors, regardless of when it began. The result feels coherent because the changes across these scales are slow compared to the travel time of light. Stability emerges not from stillness, but from the averaging effect of immense distances. At this point, human life feels briefly relevant again, not because it dominates the scene, but because it is clearly contained within it. A lifetime becomes a flicker against the backdrop of galactic light travel. Entire histories compress into what feels like a thin layer at the surface of something vastly older. You're still close enough to feel anchored. The galaxy is home. The stars feel like neighbours, however distant. The delays are enormous, but the structures remain familiar. Gravity behaves as expected. Matter arranges itself into patterns that repeat across the sky. The telescope's images at this scale feel reassuring. They confirm what was already suspected. They deepen detail without shattering context. They extend vision without demanding surrender. This is the last place where intuition remains mostly intact. Beyond the galaxy, distance stops being measured in thousands of years and begins to be counted in millions. Light now carries information from epochs so far removed that human history becomes negligible by comparison. The delay ceases to be a background detail and starts to dominate what is seen. As you stand at this edge, the familiar has been gently stretched but not broken. The idea that looking outward means looking backward has settled in without resistance. Time has loosened, but it has not yet dissolved. The telescope continues to collect light, indifferent to comfort, gathering photons that have been travelling long enough to make entire civilizations feel brief. And you move with it, outward, where delay no longer fits inside history at all. You move beyond the boundary where the galaxy can still be held as a single object. The familiar disk thins behind you, and distance stops feeling like an extension of neighbourhood and starts behaving like separation. Light now arrives after millions of years, not thousands. The delay is no longer something history can comfortably absorb. It overwhelms it. At 1,000,000 light years, the light reaching the telescope left its source before the earliest human cities formed. It began travelling while small groups of people were still shaping stone tools. Long before writing, long before agriculture became stable enough to anchor generations to one place. The photons crossed empty space while human culture existed only as fragile memory passed mouth to mouth, generation to generation, without record. Here, the past no longer feels like something you could reconstruct. It feels inaccessible, not because it is hidden, but because it unfolded without witnesses capable of preserving it. The light does not care. It arrives intact, unchanged by the absence of observers, carrying a record of structures that formed and evolved without any connection to human awareness. Nearby galaxies come into view, not as distant curiosities, but as full systems in their own right. Each one contains hundreds of billions of stars, bound together by gravity, shaped by processes unfolding over hundreds of millions of years. The telescope resolves them into spirals, ellipses, irregular forms. They look stable, complete, self-contained. But stability here is an effect of scale. The light from one edge of a galaxy can be millions of years older than the light from its centre by the time both reach the telescope. The image is already a time composite before any further delay is considered. What appears as a single moment is assembled from different eras that happen to arrive together. Human intuition strains under this. The mind wants to imagine galaxies as objects existing now, but now has fractured completely. There is no shared present across these distances. Each region contributes a different slice of its past, layered together into a coherent shape only because galactic evolution is slow compared to the time it takes light to cross them. As the scale expands further, tens of millions of light years, galaxies stop appearing in isolation. They gather into groups and clusters, bound by gravity across vast volumes of space. The light from these regions left its source before the first symbolic art appeared on Earth, before humans buried their dead with intention, before tools became refined enough to suggest planning beyond immediate survival. At this distance, human life vanishes from relevance not through insignificance, but through temporal mismatch. The delays are so long that the entire span of recorded history fits comfortably inside the travel time of a single photon. Civilizations rise, interact, fragment, and disappear while the light that will one day depict distant galaxies is still en route. The telescope records these clusters with extraordinary clarity. Individual galaxies resolve into detail. Star-forming regions glow. Dust absorbs and re-emits light. The images feel rich, alive with structure. Yet all of it is already complete before it arrives. Nothing here responds to observation. Nothing waits to be seen. This is where isolation begins to settle in. Not emotional isolation, but physical separation enforced by time. The light arriving now departed so long ago that no signal sent in response could ever affect what is being observed. Cause and effect have been permanently severed across these distances. Observation becomes strictly one way. The universe does not acknowledge the telescope. It does not adjust. It does not react. The flow of information is unidirectional, constrained by the finite speed of light and the expansion of space itself. The images feel intimate, but the connection is illusory. You're not looking across space. You're receiving remnants of long-completed processes. As hundreds of millions of light-years accumulate, clusters merge into superclusters, sprawling networks of galaxies tracing filaments of dark matter. The large-scale structure of the universe emerges, not as a pattern designed to be seen, but as an unavoidable consequence of gravity acting over immense time. The telescope reveals this structure by gathering light that began its journey when Earth itself was geologically different. At these scales, the light left its source before continents reached their current positions, before the atmosphere settled into its modern composition, before multicellular life diversified into the forms recognizable today. The planet beneath you has been rewritten many times since these photons departed. The delay now dwarfs biology. Entire evolutionary branches emerge and vanish within the travel time of light. Species appear, adapt, spread, and go extinct while the photons continue their indifferent crossing. The images condense all of this into a single frame, compressing deep biological time into a visual moment. Intuition finally fails outright. The mind cannot reconcile the apparent immediacy of an image with the depth of time embedded in it. The galaxies look present, detailed, active, yet everything about them belongs to an era fundamentally disconnected from human existence. The scale has passed the threshold where analogy helps. The telescope's role becomes clearer here. It is not a window in the ordinary sense. It is a receiver, positioned to intercept a thin cross-section of the universe's past as it passes through this location in space. The images are not scenes unfolding elsewhere, they are arrivals. Delayed deliveries shaped by expansion and distance. Expansion now asserts itself more strongly. The space between galaxies stretches as light travels through it, lengthening wavelengths, shifting energy toward the infrared. The telescope is designed to catch this altered light, not because the universe prefers infrared, but because expansion leaves no alternative. The physics dictates what can arrive. As scale increases further, approaching 1 billion light-years, the universe begins to look younger in aggregate. Galaxies appear smaller, less structured. Star formation becomes more intense. The orderly spirals common nearby give way to chaotic shapes. This is not evolution happening in front of you. It is a sequence of earlier states revealed by delay. Human history is no longer just negligible. It is absent. There is no overlap. The light reaching the telescope left before the conditions for human life existed at all. The Earth was still hostile, dominated by chemistry and geology, not biology. The concept of observation had no physical instantiation anywhere. And yet, the images remain calm. There is no violence in their arrival. The photons do not announce their age. They simply register as data, collected, aligned, processed into forms that eyes can interpret. The drama belongs to scale, not to motion. The isolation deepens, but it is not loneliness. It is clarity. The realization that the universe operates on timelines that do not intersect with experience, and that seeing does not imply participation. You're not part of these events. you're downstream from them. The telescope does not cross this distance. It does not travel back. It remains fixed, receiving what happens to reach it now. The farther it looks, the less overlap there is between what is seen and what can ever be influenced. By the time the scale reaches billions of light years, the notion of far away loses meaning. Distance has transformed into time almost entirely. To look outward is to look earlier, not as a metaphor, but as a direct consequence of physical limits that cannot be bypassed. The universe at this scale feels vast not because it is large, but because it is temporally deep. The light carries entire eras with it, eras that unfolded independently of anything that could remember them. You are carried forward into this depth without resistance. The images do not demand understanding. They apply pressure gently, steadily, until the idea of a shared present dissolves completely. Beyond this point, the past does not merely precede human history, it precedes the conditions that made history possible. And the telescope continues to receive it, photon by photon, assembling a view of a universe that existed long before anyone could wonder what it meant to see. You move farther outward, and the universe grows younger not in fragments, but in bulk. The light arriving now has been travelling for several billion years. It left its sources before the Earth developed a stable surface, before oceans settled into permanence, before life learned to leave chemical traces durable enough to be recognised as history. The delay has surpassed biology entirely. At this scale, galaxies no longer resemble mature systems. They appear compact, irregular, unfinished. Their stars burn hotter and bluer. Star formation is more intense, less regulated. Collisions are frequent, not as rare disruptions but as a dominant mode of growth. The images feel crowded, restless, thick with activity. Yet nothing is happening now. Everything you see already happened. The telescope is receiving a cross-section of a universe still assembling itself. Long before familiar structures emerged, what appears dynamic is static light, frozen by travel time, arriving all at once after billions of years in transit. The delay is now so large that Earth itself was unrecognizable when this light began moving. The planet was a molten surface cooling beneath a hostile sky. The atmosphere lacked oxygen. The sun burned slightly dimmer. The moon orbited closer. The rhythms you associate with stability did not exist. Entire geological eras pass during the time these photons spend in transit. Continents form and break apart. Ice ages come and go. Life transitions from single-celled organisms to complex ecosystems. Mass extinctions erase dominant forms and open niches for new ones. All of this unfolds while the light continues, uninterrupted, indifferent to what evolves beneath it. Human intuition no longer finds footholds here. Even deep time metaphors collapse. Billions of years exceed any inherited sense of duration. Memory, culture, and story lose relevance as reference points. The delay is not something you can imagine extending. It becomes something you must accept as dominant. Galaxies at this distance show less order because order has not yet emerged at scale. Gravity is still gathering matter. Dark matter halos are still merging. Gas has not settled into stable rotational disks. The familiar spiral shapes that once felt reassuring have not had time to form. The telescope's sensitivity allows these faint structures to appear at all. Without it, this era would remain invisible, not because it was hidden, but because its light has been stretched by expansion into wavelengths no human eye evolved to detect. The universe has not grown darker, it has grown older and larger, and the light has thinned accordingly. Expansion asserts itself continuously now. As space stretches, wavelengths lengthen, energy spreads. The farther the light travels, the more diluted it becomes. This is not lost through absorption or interference. It is geometry acting on radiation, an unavoidable consequence of a universe whose distances increase over time. The telescope compensates by collecting infrared light, not to peer deeper in a mystical sense, but to match what the physics delivers. The images feel sharp because the instrument is tuned to reality as it arrives, not as intuition expects it to be. At this depth, clusters of galaxies become less distinct. Large-scale structure remains, but it is rougher, less filamented. The cosmic web is present but still thickening, still organizing itself under gravity's slow influence. The universe looks simpler, not emptier, but less refined. Human history has now vanished completely from overlap. There is no meaningful comparison left. The entirety of recorded civilization occupies less than 0.1% of the delay embedded in these photons. Even the emergence of complex life fits comfortably inside the travel time of the light being received. This is where isolation becomes absolute. Not isolation of location, but of causality. Nothing done now could ever affect what is seen. No signal sent could arrive before the events have concluded. Observation is no longer even theoretically interactive. The telescope is positioned at a specific moment in the universe's expansion. It receives light that happens to intersect this point in space-time now. The images are not snapshots of distant places. They are slices through time intersecting the present location of the observer. The farther out you look, the narrower this slice becomes. You're no longer seeing a variety of ages mixed together. You're seeing a universe constrained to earlier and earlier epochs, approaching a time when the structures you recognize had not yet emerged. As the scale approaches 10 billion light-years, the universe shifts again. Galaxies grow smaller, fainter, more numerous. Individual systems blur into dense fields of light. The earliest large galaxies are rare. Most structures are proto-galaxies, still assembling from gas and dark matter. The light from this era left its sources before Earth's oceans condensed fully, before the crust stabilized, before any long-lived chemical cycles could establish themselves. The planet beneath you was still hostile to complexity. The concept of life had not yet found a foothold. The telescope's images compress this unimaginable span into something visually manageable. You see dots, arcs, faint smears. The mind tries to register them as objects, but they resist familiarity. Their distances erase intimacy. Their ages erase relevance. And yet, the universe feels strangely consistent. Gravity still shapes matter. Energy still flows from hot to cold. Expansion still stretches space. The same laws operate, uninterrupted, across these depths. The difference is not mechanism, but timing. At this scale, time dominates structure. What you see is less about where things are and more about when they existed. Distance has become a proxy for age. Space has become a record medium. The telescope does not interpret this. It does not mark beginnings or endings. It collects photons that have survived an immense journey and aligns them into images that respect their arrival conditions. The meaning is not encoded in the light. It emerges only when scale is allowed to press against intuition. The universe here does not feel chaotic. It feels early, less settled, less differentiated. Not because it is incomplete in purpose, but because processes that take billions of years are still underway. Human presence is not merely absent, it is impossible. The conditions that permit observers have not yet formed. The light you see began its journey before stars like the Sun were common, before stable planetary systems were widespread. The telescope's view continues to move backward through eras that no organism ever experienced consciously. The images do not carry memory, they carry structure frozen by delay. As you move outward still, the galaxies thin further, the light grows fainter, redder, more stretched. The universe approaches a threshold where stars themselves are just beginning to ignite in significant numbers. You are nearing a time when light itself was scarce, when the universe was transitioning from darkness into illumination. The delay now exceeds nearly the entire age of the cosmos. What remains ahead is not merely distant, it is foundational. And the telescope continues, receiving what little can arrive, gathering the faint traces of a universe still learning how to shine. You move into a regime where the universe no longer feels merely younger, but fundamentally unfamiliar. The light arriving now has been travelling for more than 10 billion years. It began its journey when the universe itself was less than a quarter of its current age. The delay is so dominant that nearly everything you associate with structure, stability, and repetition has not yet had time to form. At this scale, galaxies are no longer the primary reference point. Many of the systems visible are not yet galaxies in the modern sense. They are dense knots of gas and dark matter, regions where gravity has begun to concentrate material but has not finished shaping it into enduring forms. Stars ignite rapidly, burn intensely, and often die before orderly systems can emerge around them. The images appear crowded, yet incomplete. Bright points cluster tightly, surrounded by diffuse glow. Shapes overlap, boundaries blur. What once felt architectural now feels provisional. This is not because the universe is disordered, but because the processes that enforce long-term order require time that has not yet passed. The delay embedded in this light exceeds the entire span of multicellular life on Earth. While these photons travelled, life on the planet progressed from simple organisms to complex ecosystems, reshaped the atmosphere, altered the surface, and survived multiple mass extinctions. All of that biological history fits comfortably inside the travel time of the light now arriving. Human intuition has no remaining anchor here. There is no familiar timescale left to stretch. Billions of years no longer accumulate meaningfully. They dominate. The delay is not an attribute of what you see. It is what you see. Every structure, every glow, every faint smudge exists only because light has been in transit for almost the entire age of the universe. Galaxies at this distance often appear unusually bright for their size. Star formation is vigorous, driven by abundant gas and frequent mergers. Massive stars dominate, pouring energy into their surroundings, reshaping local environments quickly. These stars live briefly, measured in millions of years rather than billions, and they die violently, enriching space with heavier elements. But even these deaths are long past. The explosions occurred billions of years ago. The shock waves expanded, cooled, and dissipated while the light continued onward. The telescope does not witness violence. It receives its aftermath, smoothed by distance and time. The universe here is denser. Matter has not yet spread out as widely as it will. Distances between forming galaxies are smaller. Interactions are more common. The cosmic web is thicker, its filaments brighter relative to the voids between them. Expansion has begun to separate structures, but gravity still dominates locally, pulling material together faster than space can stretch it apart. As expansion continues during the light's journey, wavelengths lengthen dramatically. Ultraviolet light emitted by young stars arrives stretched into infrared. Energy is conserved, but redistributed. The light becomes less intense, more diffuse, harder to detect. Without a telescope designed for this regime, these eras would remain unseen. The telescope does not overcome expansion. It adapts to it. It collects what arrives, not what was emitted. The images reflect the universe as it presents itself now. After billions of years of stretching, the early universe is not observed in its original colours or energies. It is observed through the filter of time itself. At this depth, the delay has erased any overlap with Earth as a life-bearing world. When this light began its journey, the planet was still assembling. Heavy bombardment was ongoing. Water delivery was incomplete. The surface was unstable. The conditions that would later allow life to persist had not yet stabilized. Geological time itself feels compressed. The entire history of plate tectonics fits inside the delay. Mountain ranges rise and erode. Oceans open and close. Magnetic fields fluctuate. The planet repeatedly rewrites its own surface while the photons cross intergalactic space. This is where the idea of seeing the past becomes insufficient. You're not seeing past events in isolation. you're seeing a universe that existed under different average conditions, higher density, higher temperature, more intense radiation fields. The background against which all processes unfolded was not the same. The cosmic microwave background, though not directly visible here, sets the thermal floor. The universe was warmer then, not in a dramatic sense at these epochs, but enough to influence how gas cooled, how stars formed, how quickly structures assembled. These differences ripple through every image, subtle but pervasive. Galaxies here are often small, not because they will remain so, but because they have not yet merged into larger systems. Over billions of years, many of these compact objects will collide, combine, and grow. The large galaxies seen closer to home are built from countless such mergers. The telescope reveals this by showing not motion, but distribution. The abundance of small systems, the scarcity of large ones, the prevalence of irregular shapes all point to a universe still assembling itself hierarchically. This is not inferred from theory in these images, it is imposed by scale. Human history now feels not merely absent, but irrelevant. There is no reference point left where a generation, a civilization, or even a species could register meaningfully. The delay is so large that human existence occupies a vanishingly thin slice near the end of the light's journey, too late to matter to what is seen. And yet, the universe remains continuous. There is no boundary where laws change. Gravity behaves as expected. Nuclear fusion proceeds according to the same principles. Expansion follows the same equations. The difference is not in rules, but in boundary conditions. As you approach 13 billion light-years, the universe transitions again. Galaxies become rarer. Star formation begins to taper. The first long-lived stellar populations are only just becoming common. The universe is approaching a time when starlight itself was new. Before this era, the universe was darker, not empty, but opaque in different ways. Neutral hydrogen absorbed light efficiently. Large-scale illumination had not yet spread. The process that cleared this fog, allowing light to travel freely, was still underway. The telescope's reach into this period is limited not by ambition, but by physics. Light from earlier times is increasingly stretched, increasingly faint, increasingly difficult to distinguish from background noise. The farther back you go, the more the universe resists being seen. What appears in the images near this threshold feels delicate. Faint arcs, tiny clusters, marginal detections that require careful integration. These are not dramatic scenes, they are whispers, barely above the limits imposed by distance and expansion. The delay here is nearly maximal. The light left when the universe was only a few 100 million years old, when stars were rare and environments harsh, when chemistry was simple, when complexity had barely begun to accumulate. Nothing you see here overlaps with any human scale of meaning. There is no memory, no continuity, no inheritance. The universe at this time was not preparing for observers. It was simply evolving under physical constraints, unaware of what would come later. The telescope's images do not announce this as a beginning. They do not mark an origin point. They show a universe already in motion, already structured, already governed by the same rules that apply now. The beginning lies further still, beyond what light can easily convey. As you move outward into this depth, the feeling is no longer of travelling through space, but of approaching a limit, not a wall, but a thinning, a regime where fewer photons survive the journey, where information becomes scarce. The universe grows quieter, not because it lacked activity, but because the signals from that activity are stretched almost beyond recognition by the time they arrive. You are nearing the edge of what starlight can tell you. Beyond this point, the universe has not yet learned how to shine. You move into a depth where even starlight becomes unreliable as a guide. The light arriving now began its journey more than 13 billion years ago. When the universe was still emerging from its earlier structured phase, The delay is now so close to the universe's own age that the distinction between far away and long ago collapses completely. Distance has become almost entirely temporal. At this scale, the images thin dramatically. Galaxies are rare, faint, often detected only through careful accumulation of light over long exposures. Many appear as tiny concentrations barely distinguishable from background noise. These are not fully formed systems. They are the earliest assemblages of stars, the first regions where gravity gathered gas densely enough for sustained nuclear fusion to begin. The universe here is young in a strict physical sense. It is only a few 100 million years old. Expansion has cooled it enough for atoms to exist, but not enough time has passed for structure to mature. Heavy elements are scarce. Most matter consists of hydrogen and helium, forged in the first minutes after the universe began. The chemical richness familiar closer to home does not yet exist. The light from this era is fragile. As it travels, expansion stretches it to extreme wavelengths. What was once energetic ultraviolet radiation arrives as faint infrared glow. Much of it is absorbed, scattered, or redshifted beyond detection entirely. The telescope receives only a small surviving fraction, filtered by billions of years of cosmic stretching. This is not a failure of observation. It is a boundary imposed by physics. The universe does not preserve all of its past equally. Earlier light has farther to travel, and the journey degrades it. What reaches the telescope now is what could survive. Human history has disappeared so thoroughly that even the planet itself barely registers as a reference. When this light began moving, Earth had only just cooled enough to hold a crust. The atmosphere was transient. The surface was unstable. There was no continuity yet between physical processes and long-term outcomes. At this depth, entire planetary systems have not had time to form in stable configurations. Stars ignite quickly, burn intensely, and alter their surroundings before planets can settle into long-lived orbits. The environments are harsh, dominated by radiation and rapid change. The images reflect this. Star-forming regions dominate. Diffuse glows replace crisp outlines. The structures you see are transitional, fleeting on cosmic timescales. They will either merge into larger systems or be disrupted before order can persist. The telescope's ability to detect these objects depends on gravitational lensing as much as raw sensitivity. Massive clusters closer to home bend space-time, magnifying the faint light from behind them. The images you see are sometimes distorted, stretched into arcs and smeared shapes. These distortions are not artifacts. They are consequences of mass shaping the paths light must take. This bending does not add information. It redistributes it. It allows some photons that would otherwise miss the telescope to be redirected toward it. Even here, physics governs what can be seen. There is no direct view, only what the geometry of space-time permits. The delay at this scale contains nearly everything that would ever happen on Earth. Life arises, diversifies, reshapes the planet, and produces observers. All while these photons cross expanding space. The entire drama of biology is compressed into the tail end of their journey, irrelevant to their origin. The universe here is quieter not because fewer things happen, but because fewer signals survive. Star formation is intense, but brief. Massive stars dominate, live fast, and die young. Their radiation ionizes surrounding gas, slowly transforming the universe from opaque to transparent. This transition matters. Before it completes, large regions of space absorb light efficiently. Neutral hydrogen blocks photons, preventing them from traveling freely. As the first stars and galaxies ignite, they carve out bubbles of transparency. Over time, these bubbles grow, overlap, and allow light to move unimpeded across vast distances. The telescope captures glimpses of this process indirectly. Regions of darkness punctuated by faint sources, variations in brightness that reflect how far reionization has progressed. These are not events unfolding in real time. They are signatures preserved by delay. At this scale, the idea of a beginning feels close, but it remains unreachable. You're not seeing the first light ever emitted. You're seeing the earliest light that could survive to the present without being completely erased by expansion and absorption. The universe before this era was not empty, but it was opaque. Light existed, but it could not travel freely. Photons scattered repeatedly, trapped by dense plasma. No telescope could ever receive them directly. The limit you are approaching is not technological, it is physical. The images here feel sparse, almost hesitant, a few bright points against vast darkness. The contrast is extreme. The universe has not yet filled itself with structure, it is only beginning to differentiate. Human intuition struggles again, but differently than before. The difficulty is not scale, but absence. The expectation of richness meets a regime where information is scarce. The universe does not offer a clear narrative, it offers fragments. The telescope assembles these fragments carefully. It does not guess, it does not fill gaps, it reports what arrives. The result feels incomplete because the past itself is incomplete in its ability to communicate forward through time. At this depth, you're no longer watching galaxies evolve. You're watching the conditions that make galaxies possible emerge unevenly across space. The universe is transitioning from simplicity to complexity, from uniformity to structure. The light you see began its journey when the universe was still deciding how transparent it would become. Many photons never made it. The few that did carry disproportionate weight, not because they are special, but because they survived. You are now near the limit of what starlight can convey. Beyond this point, the universe has not yet opened itself to observation in this way. The signals thin further, the darkness deepens. The telescope continues to receive what it can, patiently, without preference, gathering the faintest traces of a universe still emerging from its earlier shadow. And you move with it, closer to a boundary that is not an edge of space, but an edge of visibility. You move into a regime where even survival of light is no longer assumed. The photons arriving now began their journey when the universe was less than 5% of its current age. The delay has reached a point where nearly all familiar structures, galaxies, stars, planets were either absent or only beginning to appear in rare, unstable pockets. Here, the universe is not yet transparent everywhere. Vast regions remain filled with neutral hydrogen, efficient at absorbing and scattering light. Radiation does not cross space freely. It is intercepted, redirected, erased. What reaches the telescope has navigated a narrowing corridor of possibility, slipping through expanding regions of transparency as the universe slowly changes its own optical properties. The images thin further. What remains is sparse and uneven. Brightness varies sharply from place to place. Darkness dominates not because nothing exists, but because light cannot yet travel unimpeded across most of space. The universe has matter, energy, motion, but not clarity. The delay embedded in this light is so long that Earth itself had not yet completed its formation when the photons began moving. The planet was still accreting material. Impacts were frequent. The surface was molten. There was no continuity from moment to moment, no stable environment where complexity could persist. At this scale, time overwhelms all biological intuition. The entire evolutionary arc of life on Earth, from its earliest chemical precursors to conscious observers, unfolds long after these photons have already departed their sources. Nothing about human existence overlaps with what you see here, not even indirectly. The telescope registers only the most extreme sources, the earliest massive stars, the densest star-forming regions, the most energetic assemblies of matter. These objects shine brightly enough, briefly enough, to punch holes in the surrounding opacity. They carve out local volumes where light can escape, at least temporarily. These stars are unlike those familiar nearby. They form from nearly pristine gas, almost entirely hydrogen and helium. They are massive, short-lived, intensely luminous. Their radiation reshapes their environments rapidly, heating and ionizing surrounding material, altering how future light will propagate. But even these stars vanish quickly. They burn out, collapse, explode, or fade on timescales short compared to cosmic history. The telescope does not witness their lives. It receives their remnants, delayed by billions of years, arriving long after the stars themselves have ceased to exist. The universe here is undergoing a phase transition, not dramatic in appearance, but fundamental in consequence. As ionized regions expand and merge, space becomes increasingly transparent. Light that once would have been trapped can now travel farther. The universe is slowly allowing itself to be seen. This process is uneven. Some regions clear early, others remain opaque for longer. The images reflect this patchiness. Bright islands appear against a dark background. The pattern is not random. It is governed by the distribution of matter and the intensity of early star formation. Human intuition searches for familiar markers, clusters, disks, spirals, but finds none. The universe has not yet organized itself into enduring shapes. What exists is transient, rapidly evolving, dominated by extremes rather than balance. The telescope's role becomes increasingly passive. It cannot force clarity where none exists. It cannot retrieve information that never escaped. It simply waits, collects, integrates. What emerges is not a full picture, but a boundary condition. The light reaching the telescope from this era carries with it not just information about sources, but about the medium it crossed. Absorption features imprint themselves on the spectrum. Gaps appear where light was removed. These absences are as informative as presences, indicating where neutral hydrogen still dominated. This is not inference layered onto data. It is data shaped by constraint. The universe communicates its state through what is missing as much as through what remains. At this depth, the idea of seeing the beginning becomes untenable. There is no single moment to witness. There is only a gradual transition from opacity to transparency, from uniformity to structure, from silence to signal. The telescope's images do not show a universe switching on. They show a universe slowly becoming permeable to its own radiation. The beginning, if it can be called that, is smeared across hundreds of millions of years. The delay now approaches the maximum possible for light emitted by stars. Beyond this era, stars are too rare, environments too opaque, signals too degraded to survive the journey intact. The universe before this time does not offer starlight as a messenger. Human history, biology, even planetary formation are now far downstream. They are consequences of processes still underway here, not participants in them. The connection between observer and observed has stretched until it is purely causal, with no overlap in existence. The images at this scale feel austere. Few points, large voids, extreme contrasts. They resist narrative. They resist interpretation beyond what physics enforces. They are records of conditions, not scenes. The telescope does not cross this boundary. It approaches it asymptotically, limited by what the universe allows to escape. Each additional increment of distance yields diminishing returns. Fewer photons, less structure, more uncertainty. You are now very close to the furthest point starlight can reach you from. Beyond this, light itself cannot carry structure forward in time. And yet, the universe continues further still, into an era where light existed but could not travel freely, where radiation and matter were tightly coupled, where visibility as a concept had not yet emerged. The telescope cannot show you that directly. It can only bring you to the edge, where signal fades into opacity, and the universe's earliest history slips beyond the reach of sight. You move into a region where the word image itself begins to lose precision. The light arriving now has travelled for more than 13.5 billion years, emerging from a universe so young that even the rarest stars were newcomers. The delay is now within a small margin of the universe's own age. There is almost no temporal separation left to compress. Here, the universe is only a few 100 million years old. Structure exists, but barely. Gravity has begun its work, drawing matter into the first concentrations, but the outcome is uncertain and uneven. Many regions have not yet produced stars at all. Others flare briefly, then fade, leaving little behind that can transmit information forward. The images are no longer filled with objects. They are punctuated by absences. Darkness dominates, not as emptiness, but as silence. Most of what exists cannot be seen because it does not radiate light that can escape. The universe is present, active, evolving but largely invisible. The delay embedded in these photons now exceeds the time it took for Earth to become habitable, for life to arise, and for complex organisms to evolve. Everything that would ever make observation possible unfolds entirely after this light has already left its sources. The observer exists only at the very end of the signal's journey. The universe here has not yet settled into the patterns that will dominate later eras. There are no stable galactic disks, no long-lived stellar populations, no accumulated chemical diversity. The matter that will one day form planets, oceans, and organisms is still cycling through brief, violent phases. Expansion continues relentlessly. Space stretches as light travels, thinning signals further. Wavelengths lengthen until energy becomes diffuse, barely distinguishable from background. The universe does not preserve detail from this era easily. It allows only the most extreme emissions to survive. The telescope collects what little arrives: faint points, marginal detections, patterns that must be integrated over long time to rise above noise. These are not scenes unfolding elsewhere. They are the final traces of processes that ended billions of years ago, barely loud enough to cross the gulf. At this scale, causality has become absolute. Nothing that happens now could ever influence what is seen here. There is no hypothetical interaction left, no delayed response possible. The light has completed its journey. The events that produced it are sealed off forever. Human intuition does not collapse here. It quiets. There is nothing left to compare. No metaphor holds. The scale does not feel vast so much as final. You're not approaching something dramatic. You're approaching the point where information thins beyond recovery. The universe before this era is not hidden behind distance. It is hidden behind physics. Earlier light existed, but it could not travel freely. Photons scattered constantly, trapped in a dense plasma of charged particles. Space was filled with radiation, but visibility had no meaning. The telescope does not peer into this opacity. It cannot. No improvement in sensitivity would help. There is no path for that information to take. The universe itself had not yet created the conditions necessary for light to function as a messenger. What you see at this boundary is not the first light, but the first light that could endure. It marks a transition, not a beginning, a moment when the universe became transparent enough in places for information to survive the long expansion to the present. The images here feel restrained, almost hesitant. They do not overwhelm. They offer hints rather than declarations. The universe is still in the process of revealing itself, but only partially, unevenly, with long gaps of silence between signals. Human history, culture, memory, none of it belongs here. These photons departed before any process that could value them existed. Their journey was not undertaken to be seen. Their arrival now is an accident of alignment between emission, expansion, and detection. The telescope does not frame this as a climax. It does not mark an origin point. It simply records the furthest reach of what starlight can convey. Beyond this, stars are too rare, opacity too high, signals too degraded. You are now at the effective edge of visual cosmology, not because the universe ends here, but because this is where the universe stops being able to show itself through light emitted by stars and galaxies. Beyond this boundary, different messengers would be required, radiation of a different kind, imprints left not by individual objects, but by the universe as a whole when it was still hot, dense, and uniform. The telescope was never designed to see that directly. Its purpose was to gather the last whispers of a universe that had only just begun to speak. And as you hover at this threshold, what remains ahead is not darkness in space, but darkness in time and era where the universe existed, evolved, and expanded without leaving behind images that could ever arrive here intact. You move into the final stretch not by going farther, but by approaching a limit that cannot be crossed by looking. The light arriving now has travelled almost the full age of the universe. The delay has become so complete that it no longer feels like a property of the signal, but like the defining condition of everything you are able to receive. Here, the universe is no longer organised around stars or galaxies at all. Those structures are only just beginning to emerge, sparsely and unevenly, and most regions have not produced them yet. The dominant feature is not form, but uniformity. Matter is distributed smoothly on large scales, with only slight variations in density variations that will one day grow into everything that follows. The images at this boundary are minimal. There are few points of light, and they carry little detail. The telescope is no longer assembling scenes. It is intercepting the last viable carriers of structure that can survive the journey from that era to now. What you see feels fragile because it is. The delay now contains nearly the entire history of the universe. When these photons began their journey, the cosmos was only a few 100 million years old. It had cooled from its initial extreme temperatures, but it was still young, still dense, still close to uniform. The large-scale differences that dominate later epochs were only faint imprints. Human history, biology, and even planetary formation are no longer downstream events here. They are consequences of conditions barely visible in these images. Everything familiar unfolds long after this light has already passed the point where Earth would one day exist. At this scale, the idea of what James Webb really saw resolves into something quieter than headlines suggest. The telescope did not see a beginning. It did not see creation. It saw the universe at the earliest time when light could still carry structured information forward without being completely erased. The boundary you're touching is set by recombination and opacity. Before atoms formed, charged particles scattered photons relentlessly. Light existed, but it could not travel freely. Space was luminous, but opaque. No image could survive. No direction mattered. Visibility, as a concept, had not yet emerged. The universe after that transition slowly became transparent, first to long-wavelength radiation, then to starlight in limited regions, then more broadly as the first luminous objects reshaped their surroundings. The telescope's view reaches only as far back as this gradual opening allows. What lies beyond is not empty and not unknowable in principle, but it is inaccessible to this method. The information from earlier times is not lost, it is encoded differently. It exists as statistical patterns, as background radiation, as subtle correlations imprinted across the sky. It does not arrive as images. The telescope's images at this edge therefore feel understated. They do not dramatize the moment. They do not signal an origin. They show a universe already governed by the same physical laws as today, already expanding, already cooling, already carrying within it the seeds of everything to come. The scale has now fully replaced intuition. Distance is time. Seeing is receiving. The present is local and fleeting, while the past dominates what arrives from afar. There is no shared now beyond a narrow region around you. And yet, this does not leave you isolated. It situates you precisely. You exist at a point where the universe has become transparent enough, structured enough, and old enough for information to accumulate, persist, and be understood. The images are possible only because you're standing at the far end of a very long causal chain. James Webb did not look back to a moment when the universe began. It looked back to a moment when the universe first allowed itself to be seen in this way. What it collected were not answers, but boundaries edges imposed by expansion, opacity, and time. The telescope gathered light that survived almost everything: cooling, stretching, absorption, loss. What arrived did so because it could, not because it was meant to. That survival is the only selection principle at work. At this furthest scale, the universe does not feel vast in space. It feels deep in time. The immensity is not measured in kilometers or light years, but in the accumulation of processes layered one upon another, each dependent on what came before. You're not looking at the beginning of time. You're looking at the earliest chapter that can still be read. And beyond that chapter, the universe does not disappear. It simply stops speaking in images. You return now, not by moving inward, but by letting the scale settle. Nothing collapses. Nothing snaps back. The distance you've crossed does not reverse itself. It simply stops expanding, like a held breath finally released. What remains is not an image of the beginning, but a clearer sense of where you are standing. You are here, at a moment when the universe has already done most of its quiet work. Expansion has cooled it enough for atoms to persist. Gravity has had time to gather matter into enduring structures. Stars have lived and died in sufficient numbers to seed space with heavier elements. Planets have formed, stabilized, and survived long enough for chemistry to become patient rather than explosive. This was not guaranteed. Nothing in the earlier universe pointed toward this outcome as a destination. It emerged because the physical constraints allowed it, slowly, unevenly, without foresight. The telescope's images do not tell a story of intention. They tell a story of allowance. They show you how much had to happen before looking back became possible at all. The light James Webb collects arrives here only because it endured an almost impossible journey. It crossed a universe that expanded beneath it, stretching its wavelength, thinning its energy, filtering its signal. It passed through regions that were once opaque, then marginally transparent, then increasingly open. Most light from those eras did not survive. What you see is what could. This does not make the images special in a human sense. It makes them precise. They are records shaped by constraint rather than choice. And you, receiving them now, exist at the far end of that constraint. Human life occupies a narrow interval at the trailing edge of cosmic time. That is not a diminishment. It is a condition. The universe had to be old enough, calm enough, structured enough for observers to appear at all. You're not early. You're not late. You're exactly where observation becomes viable. The scale you've moved through replaces a simpler intuition with a sturdier one. You no longer expect the universe to share your present. You no longer expect distance to behave like extension. You understand, without effort now, that seeing is receiving, that light is history in motion, that every image is a delayed arrival shaped by expansion and loss. This understanding does not isolate you, it locates you. You're not disconnected from what you see because you cannot influence it. You're connected because you are downstream from it. Every atom in your body was forged in environments like those faint galaxies. Every chemical complexity that sustains you required generations of stars to live briefly and die long before the Earth existed. The delay that separates you from the early universe is the same delay that made you possible. When the telescope looks outward, it is not leaving you behind. It is tracing the conditions that allowed this moment to exist. The faintness of the images is not a failure of reach. It is a measure of how long the chain of causality had to be. What James Webb really saw was not the beginning of time, but the earliest surviving evidence of a universe becoming readable. It saw the transition from opacity to openness, from uniformity to structure, from silence to signal. It marked the point where the universe first began to leave records that could last. That boundary is not dramatic, it is quiet. It does not announce itself. It simply limits how far back images can speak. Beyond it, the universe still exists. Its history continues deeper than light can carry. That history is not absent. It is encoded differently, in background radiation, in statistical patterns, in correlations that span the sky. Those records require different instruments, different approaches, different intuitions. But they rest on the same foundation you now feel that the universe does not rush, does not aim, does not explain itself. It unfolds under constraint, and what survives forward is what you can know. This perspective does something subtle. It removes urgency. There is no race to see everything, no expectation that the universe owes revelation. The images arrive when they arrive. Understanding accumulates when conditions allow. You're not standing at the end of knowledge. You're standing at a moment when knowledge has become possible in this particular way. The emotional arc closes gently here. The vastness does not threaten. The isolation does not linger. The humility settles into proportion. You are small, but not misplaced. Brief, but not accidental. Connected, not by proximity, but by causality. The universe you inhabit is one where light can travel, matter can organize, and memory can persist. That alone is extraordinary, without requiring drama. When you look again at those images, at the faint smudges, the distorted arcs, the barely visible points, you no longer need them to represent a beginning. They represent endurance. They represent how much had to go right, physically, for anything to arrive at all. And you are part of that arrival, not as a witness set apart, but as a continuation of the same processes, operating now under calmer conditions, slower changes, longer feedback loops. The laws have not changed. The scale has. The universe did not wait for you. It did not prepare. It simply unfolded long enough for this moment to exist, where looking back is possible, meaningful and stable. That is where you are. And from here, the night sky is no longer distant. It is layered, not separate from you, but stacked behind you in time, holding the record of how this moment became reachable. You don't need to carry the vastness with effort anymore. It carries itself. And you are free to stand inside it, grounded, oriented, and at ease.